Hello students all over the world. Once again, you are welcome to our series of lectures on complex numbers. I am your lecturer, Professor E.O. Efang. This is the 7th lecture in this series, and our topic is nth root of unity and its geometric meaning. We recall that the nth root of a complex number z equals to r exponent I theta are given by zk equal to nth root of r into cos theta k plus I sin theta k, where theta k is equal to theta plus 360k all over n for k equals to 0, 1, 2 to n minus 1. Now, for z equal to 1, r is equal to 1 and theta is equal to 0. So, our nth root of unity are now given by the formula zk equal to cos theta k plus I sin theta k. That is when you put r equals to 1 here. We have the nth root of 1 is 1. Then times this will give us zk to be equal to cos theta k plus I sin theta k, and our theta k will now become theta k equals to 360k all over n for k equals to 0, 1, 2 to n minus 1. Please note theta is 0 here, so when you put 0 then plus 360k, that will give us 360k all over n. Let us now take some examples. Example 1. Find the square root of z equal to 1. Solution. Here n is equal to 2 because we are finding the square root. So theta k is equal to 360k all over 2 for k equals to 0 and 1. For k equals to 0, we have theta 0 equals to 360 times 0 all over 2, which is equal to 0 over 2, and that is 0 degrees. And for k equals to 1, we have theta 1 equals to 360 times 1 all over 2. That's 360 over 2, which is equal to 180 degrees. So therefore, the square root of unity are zk equals to cos theta k plus I sin theta k for k equals to 0 and 1. For k equals to 0, we have z0 equal to cos 0 plus I sin 0. Cos 0 is 1, sin 0 is 0, so that will give us 1. And for k equals to 1, we have z1 equals to cos 180 degrees plus I sin 180 degrees. 180 degrees is in the second quadrant. Cos is negative in the second quadrant and sin is positive. To find the trig ratios for the angles in the second quadrant, we have to subtract the given angle from 180. So this will give us minus cos 0 degrees plus I sin 0 degrees. Cos 0 is 1, sin 0 is 0, so this will give us minus 1. So the square root of unity are z0 equals to 1 and z1 equals to minus 1. Example 2. Find the cube root of z equals to 1. Solution. Here n is 3. So theta k is equal to 360k all over 3 for k equals to 0, 1 and 2. For k equals to 0, we have theta 0 equals to 360 times 0 over 3, which is 0 over 3, and this is equal to 0 degrees. For k equals to 1, we have theta 1 equals to 360 times 1 all over 3, which is equal to 360 over 3, and this is equal to 120 degrees. And for k equals to 2, we have theta 2 equals to 360 times 2 all over 3, which is equal to 720 over 3, and this is equal to 240 degrees. So therefore, the cube root of unity are zk equals to cos theta k plus I sin theta k for k equals to 0, 1, and 2. Now for k equals to 0, we have z0 equals to cos 0 degrees plus I sin 0 degrees. Cos 0 is 1, sin 0 is 0, so this is equal to 1. For k equals to 1, we have z1 equals to cos 120 degrees plus I sin 120 degrees. 120 degrees is in the second quadrant. Cos is negative in the second quadrant, while sin is positive in the second quadrant. To find the trig ratios for the angle in the second quadrant, we recall we have to subtract the given angle from 180 degrees. So this will give us minus cos 60 degrees plus I sin 60 degrees. Cos 60 degrees is 1 all over 2, while sin 60 degrees is root 3 over 2. So z1 is equal to minus half plus root 3 over 2i. Now for k equals to 2, we have z2 equals to cos 240 degrees plus I sin 240 degrees. 240 degrees is in the third quadrant. Cos is negative in the third quadrant, and sin is also negative in the third quadrant. To find the trig ratio for the angles in the third quadrant, we have to subtract 180 from the given angle. So this is equal to minus cos 60 degrees minus I sin 60 degrees, which is equal to minus 1 all over 2 minus root 3 over 2i. So the cube root of unity are z0 equals to 1, z1 equals to minus half plus root 3 over 2i, and z2 equals to minus half minus root 3 over 2i. Example 3. Find the fourth root of z equal to 1. Solution. Here n is equal to 4, so theta k is equal to 360k all over 4 for k equals to 0, 1, 2, and 3. For k equals to 0, we have theta 0 equals to 360 times 0 over 4, which is 0 over 4, and that is 0 degrees. For k equals to 1, we have theta 1 equals to 360 times 1 all over 4, which is 360 over 4, and that is equal to 90 degrees. For k equals to 2, we have theta 2 equals to 360 times 2 over 4, which is 720 over 4, and this is equal to 180 degrees. And for k equals to 3, we have theta 3 equals to 360 times 3 all over 4. That is 1080 over 4, which is equal to 270 degrees. So therefore, the fourth root of unity are zk equals to cos theta k plus I sin theta k for k equals to 0, 1, 2, and 3. Now for k equals to 0, we have z0 equals to cos 0 degrees plus I sin 0 degrees. Cos 0 is 1, sin 0 is 0, so this will give us 1. For k equals to 1, we have z1 equals to cos 90 degrees plus I sin 90 degrees. Cos 90 degrees is 0, sin 90 degrees is 1. 1 times I will give us plus I. For k equals to 2, we have z2 equals to cos 180 degrees plus I sin 180 degrees. 180 is in the second quadrant. Cos is negative in the second quadrant, and sin is positive. To find the trig ratios for the angle in the second quadrant, we recall we have to subtract the given angle from 180 degrees. So this will give us minus cos 0 degrees plus I sin 0 degrees, which is equal to minus 1. And finally, for k equals to 3, we have z3 equals to cos 270 degrees plus I sin 270 degrees. 270 degrees is in the third quadrant, cos is negative in the third quadrant, and sine is negative in the third quadrant. To find the trig ratio for the angle in the third quadrant, we have to subtract 180 from the given angle. So this will give us minus cos 90 degrees minus I sin 90 degrees. Cos 90 degrees is 0, sin 90 degrees is 1. 1 times minus I will give us minus I. So therefore, the foot root of unity are z0 equals to 1, z1 equals to plus I, z2 equals to minus 1, and z3 equals to minus I. Now, let us look at the geometric meaning of nth root of unity. For n equals to 2, the nth root of unity corresponds to the end point of diameter of a unit circle with center at the origin and end point at the point 1, 0 and minus 1, 0. For n greater than 2, the nth root of unity corresponds to the n vertices of the regular polygon of n sides in a complex plane inscribed in a unit circle with center at the origin and one vertex at the point z equal to 1. Now let us look at each of them geometrically. Geometric meaning of square root of 1. For n equals to 2, z0 is equal to 1 and z1 equals to minus 1. So we show this geometrically as follows. This is the real axis while this is the imaginary axis. This is a unit circle with center at the origin, and the point z equal to 1 is this. This is the point z0, while this is the point z1 equals to minus 1. So you can see the point z0 and z1 are the end point of this diameter. Let us look at the geometric meaning of the cube root of 1. That is for n equals to 3, z0 equals to 1, z1 equals to minus half plus I root 3 over 2, while z2 is equal to minus half minus I root 3 over 2. So we show this geometrically as follows. This is our real and imaginary axis with a unit circle with center at origin. This is the point z0, while this is the point z1, and this is the point z2. So you can see that these 3 points are vertices of a regular triangle. Now, geometric meaning of the foot root of unity. Here n is equal to 4, z0 is equal to 1, z1 equals to I, z2 is minus 1, and z3 is minus I. Geometrically, we can display this as follows. This is the real and the imaginary axis with a unit circle center at the origin. This is the point z0, this is the point z1, this is the point z2, and this is the point z3. And this point z0, z1, z2, and z3, you can see are the vertices of a square inscribed in this unit circle. We have come to the end of lecture 7. Thank you for watching and keep on watching. I remain your lecturer, Professor E.O. Ivan.